Welcome, everyone. I am back with Frances, and I say I'm back with Frances because you know I met Frances last year at CPP on C. She helped us with volunteering. She helps run the lightning talks at CPP on C. She's got some great books. A wonderful one on C++. If you're working on catching up with C++, which I have to say I wrote a review because it's awesome. It's like a nice, concise, and you get some really new modern stuff. And you're giving a talk, of course, this year at CPP on C. Swarm Your Way Out of a Paper Bag is the subtitle. I'll let you go with the whole title.
So it starts an introduction to swarm intelligence algorithms, which is a little subset of AI and machine learning, which quite a few people don't know anything about. And the maths in it is way easier than neural networks and all these LLM stuff. So if your maths is a bit hazy or something, it just involves multiplying, adding up, and subtracting. So it's nice and simple, but you get a glimpse of how more complicated things work. And it's a real cool little project to try out yourself, practice your C++ or any other language. So you learn some AI, you practice some C++, and this time I'm going to focus on the cat swarm algorithm, or as I like to say it, herding cats. So we see if we can herd some cats out of a paper bag.
Are dogs involved? I mean, I think I just got to make a dog joke because I can get cats out of a paper bag with one dog pretty quick.
Oh no! Well, maybe we should try that as some kind of predator prey type model another year. But this year, just cats. Sorry.
Okay. That's all right. I look forward to seeing cats work their way out of paper bag. You've been doing genetic algorithms and AI stuff for a while, though, haven't you?
A very long time. Way back last century, I did a PhD in machine learning, and my main focus ended up being genetic algorithms. So I still keep practicing them and finding variants of this kind of thing, just as an excuse to practice coding, really. Ambers are fun, ambers are interesting. And you can find out surprising things by doing some quite simple AI machine learning stuff. So, yeah, a bit of a silly hobby, but keeps me entertained.
Yeah. And I'm really kind of interested now, too, because like you said, everybody's talking about LLMs, which to be an oversimplification is just like the biggest pattern recognition system we probably have outside of our brain. And so it's interesting to hear that it's using basic math to be able to do a swarm algorithm. I mean, and I'm imagining that, I don't want you to give away too much stuff because everybody needs to come to the talk, but how does that kind of present itself? Like when I think of LLMs, it's like the understanding I have is once we understood synapses and how the brain was doing more of that, then we were able to start making the models more similar in the way the brain works. But how does that work from the swarm intelligence kind of point of view?
So it's really simple. And the kind of go-to example of swarm algorithms is something called a particle swarm algorithm. So it's just a generic thing. If we use a paper bag analogy, if you've got XY coordinates and you want to solve a problem, like find optimal XY position for something, that there might be a position in space or two numbers to solve some logistics problem. You just randomly pick some XY points. So you've got loads of particles, and you give them all a random velocity. And that's the nub of all the swarm algorithms. They've got a position and a velocity, so they're tending to go in one direction. And you see which one's doing best. And each particle remembers where was best that it's been. And then they all move, just each time step, however much velocity moves them. And then you update each one, maybe to nudge towards its favourite place so far, or the best place it's been to so far. And because it's a swarm, you always look at the global best as well. So you nudge that way slightly. So everything will start moving towards a better place. But it's probabilistic, so they don't all end up in the same place. And that allows them to explore several XY points. So you basically take your current X position and add the velocity in the X direction. Same with Y. You can go crazy and add Z, so you've got 3 dimensions, or etc., etc.
Wow.
So as you're adding up, your subtractions coming from the distance between here, where I am now, and the best place overall, or my best place too. And then you multiply maybe 50% of my favourite place or 50% of the overall favourite place. Adding up, subtracting, multiplying. And the blobs, particles, whatever they are, will gradually move in on some points. And you can use this to solve really complicated problems. We'll do something simple in the talk.
And then everybody wants to come see the talk because then when they have their questions of how to solve the complicated thing, they can talk to you afterwards and get even more details.
Well, yes, except I'm talking on Wednesday and then we're rolling straight into the lightning talk. So there's going to have to be a long evening of chat. But because it's Wednesday, I'm around all week, so be able to talk later.
And that's exactly why, if you don't have tickets yet, you got to come to cpponsea, see Frances's talk, watch her swarm some cats out of a paper bag. I still think we need the dog involved, but I'm a dog person, so that's just me.
Next time, definitely.
I appreciate your time today, Frances. I'll see you at cpponsea.
Excellent. See you there. Cheers.
Bye-bye. Cheers.
Bye.